In today's discussion on electrical measurement, we will talk about DC potentiometer. In our discussion, we will first define DC potentiometer. What are the characteristics of this type of potentiometer? How this potentiometer works? Then we will discuss about Vernier potentiometer, the calibration techniques of voltmeter, ammeter and wattmeter. What are the pros and cons of a DC potentiometer? The application domains of DC potentiometer, and finally we will conclude with waste on normal cells. A potentiometer is a system of resistors used with a standard cell and a galvanometer for null measurement of potential. A potentiometer is also called a pot or a potmeter, and it is a variable resistor whose resistance is manually varied to regulate electrical current flow. Pot acts as an adjustable voltage regulator. A DC potentiometer is a potentiometer whose power is supplied by a battery and the balance is achieved under direct current conditions. The potentiometer is made up of German silver or manganese ore and is about 1 meter long. It is a passive component, that is, it does not require power of its own, but the system to which it is attached needs external power supply for operation. It is different from a rheostat, which has only one fixed and one movable contact. Following are a few salient features of a DC pot. It offers high accuracy as it involves compression method and not deflection pointer method. No power is required as it involves null or balance point. The potentiometer working is free from the source resistance as no current flows through it in balance condition. It is a three-terminal device with two fixed points and one sliding contact called as wiper over a uniform resistance. Based on the movement of the wiper, the potentiometer can further be categorized as linear or rotary type. The picture on the left represents a DC potentiometer. It is seen that it has two fixed points and one movable wiper around the cylinder. This potentiometer structure is fixed on any circuit of whose current, voltage or power is to be measured. The slide wire has uniform cross-sectional area. The equalizing process of the working potential due to voltage drop is called standardization. The switch establishes the connection with the galvanometer. It toggles between operation and calibration and offset. The battery through the rheostat is the power supply unit of the system. The galvanometer is balanced at zero deflection by sliding the wiper and value is noted. Vernier potentiometer is one special arrangement by which we can enhance the resolution of a DC potentiometer. The instrument can have a resolution of as low as 10 microvolt for reading up to 1.6 volt. A Vernier potentiometer uses three measuring dials consisting of 102 studs each in the second and the third dial. The first dial ranges between 0 and 1.5 volt with step change of 0.1 volt. The second has a range of 0 to 0.1 volt and the step changes take place in 0.001 volt steps. And the third dial measures maximum of 0.001 volt in steps of 0.00001 volt, that is 10 microvolt. The picture on the right shows an actual laboratory Vernier potentiometer, and the picture on the left shows the three dials of a Vernier potentiometer, one below the other. One of the principal applications of a DC potentiometer is to calibrate devices like voltmeters, ammeters, and wattmeters. The calibration is aimed to enhance the accuracy and the correctness of any instrument by comparing the measured value with the standard value. Here, the standard value is the potentiometric value. A potential divider network and a stable DC supply are used, which are connected to two rheostats. One rheostat is for coarse adjustment and the second one is for fine adjustment. The calibration is done by fine adjustment of the rheostat connected in series with the DC supply. The volt ratio box steps down the voltage across the voltmeter so that our range of operation can be specified. The voltmeter accurate value is determined by measuring the maximum possible voltage value in the range of the potentiometer. As already mentioned, for voltage calibration or the calibration of a voltmeter, the setup comprises a stabilized DC supply, a potentiometer which is considered to be the standard, a voltage ratio box to step down the measuring voltage, the voltmeter that is under calibration. In parallel with the voltmeter, we connect one coarse adjustment and one fine adjustment rheostat. The potentiometer measures the maximum possible voltage values. Errors, both positive and negative, occur due to mismatch of reading between the pot and the voltmeter. Another very important device in electrical measurement is the ammeter used to measure current. A standard resistor is connected in series with the ammeter under calibration as shown in the picture here. The potentiometer measures the voltage across this standard resistor S, and the current is calculated by the formula I equals Vs by S, where I is the current through the circuit and Vs is the voltage drop across the standard resistor. As standard resistance value and the voltage across the pot are accurately known, the calibration of the ampere meter, that is ammeter, is very accurate and very precise. Wattmeter is the device that measures the power consumed in the circuit. Here, just like the ammeter, a standard resistor is connected in series with the wattmeter, which is under calibration. It comprises two coils, the current coil and the voltage coil, and the current coil is connected to the low voltage supply and the voltage coil to the main or the principal voltage supply respectively by a voltage divider. The voltage coil potential is measured by the pot directly. The current coil current is measured by measuring the voltage drop across the standard resistor S. The current is adjusted by a rheostat connected in series with the current coil. As already mentioned, the setup of the wattmeter calibration is shown in the picture given. It principally has two coils, the voltage coil and the current coil. The power or the wattage is given by the formula P equals VI. The volt ratio box steps down the voltage. The potentiometer connected via DPDT relay measures the actual V and I values. The wattmeter value and the relay switch values are compared. Wattmeter is adjusted for calibration. DC potentiometers offer a lot of advantages in form of high reliability, high accuracy. It has a very compact size. It offers negligible resistance drift. It is unaffected by the environmental conditions like vibration, humidity, shock, or wiper contamination. DC potentiometers do not have any moving part other than the wiper, and therefore the tolerance is as good as plus minus 1%. It is a very low power dissipation device. However, there are certain limitations for a DC potentiometer, and those are that it is not suited for high temperature operation, as at high temperature the resistance value changes. It is not suitable for high power applications also. The non-linearity of the wiper resistance adds harmonic distortion to the output. Parasitic capacitance also influences the output. Measurement of resistance, voltage, current and power and calibration of voltmeter, ammeter and wattmeter are the applications of DC potentiometer. Throughout the discussion, we talk about a stabilized DC supply for DC potentiometer. Western normal cell is a wet chemical cell that can produce such a very high stable voltage supply. The anode is an amalgam of cadmium and mercury, and the cathode is pure mercury having a paste of mercurous sulfate and mercury. The electrolyte is a saturated solution of cadmium sulfate with a depolarizer of mercurous sulfate, and the connection wire is made up of platinum. The main advantage of Western normal cell is that it is unaffected by temperature changes, so it is highly durable and highly effective in measurement. The picture shows the anode and the cathode composition of a Western normal cell. At the anode, the cadmium loses 2 electrons to give aqueous cadmium ion, and at the cathode, mercurous sulfate reacts with the 2 free electrons to give mercury liquid and form sulfate 2 negative ion. For further and more detailed reading, the students can refer to the following links. Thank you.